For each of these, determine possible functions f and g, so y equals f and g of x. And with multiplying and adding and subtracting, I kind of made fun of these questions, because you could always make the first one exactly the same as what you started with, and there was sort of a cheating method. However, for composition of functions, it's actually important in calculus to be able to recognize when one function is inside of another. So right now here, the g of x is inside of f of x. So in part A, can you see that the x minus 2 is inside of something getting cubed? So my inside function, g of x, could be the x minus 2. And my outside function, f of x, is cubing. So I have my outside function cubing my inside function. Okay. There is a way to cheat on these ones, but for calculus, it is actually important to be able to see one function inside of another. So this is actually important. If you wanted to cheat, for sure, you could make f of x exactly what you wanted. X minus 2 cubed. And then the inside function just is x. It's right, but in this case, it kind of defeats the purpose. You could flip-flop it. You could have made g of x the whole thing you wanted, and f of x just x. So either of those would work. But it is important to see one function inside of another, and I think visualization of these is not hard. You see that 3 plus x is inside a square root. So we would make our inside function the 3 plus x. And the outside function is square rooting, so we just need to square root whatever we put in. It's just the square root of x. Okay? Not too hard, but it will be important. Important for calculus. Okay.